For the equation y equals negative 2x minus 4, find the y-intercept. Also, graph the equation by hand. So we're going to take our y equals negative 2x minus 4. We're going to take this equation and we're going to see if we can come up with a minimum of three solutions to that linear equation. Three values for x and y, so three ordered pairs that when we put the x value in and the y value in, it would make the equation true. So how we're going to do that is we're going to just start by choosing some values for x that we can then plug into the equation and find the corresponding value for y. Now, a nice value for x to choose, and this is almost always true, is to let x equal 0. And the reason that that's so helpful is that when I multiply things by 0, it doesn't change them. When I add 0 to things, it doesn't change them. So it tends to make the math pretty easy. So what we want to do now is to find the y that's going to go along with that. So we will say y equals negative 2x. Well, remember we chose a value for x. We let x equal 0. And so let's put that in for the x value. And then minus 4. And now we're just going to simplify this out. Y equals, well, notice negative 2 times 0 is just 0. 0 minus 4. And so we're going to end up with a y value of negative 4. 0 minus 4. So there's one ordered pair, 0, negative 4, that's going to be a solution to my equation. So it's also going to be a point on my graph. So I can go ahead and plot that right now. There's 0, negative 4 right there. Now we can choose any two other values for x. There are no right or wrong values for x to choose. Now there can be smart values and not so smart values, or easier values and harder values. But certainly we have lots of leeway for the values of x that we choose. But once we choose the value for x and we plug it into the equation, we substitute it in, there's only going to be one value for y that's going to correspond with that. So let's just try, I'm just going to pull the number 2 just for fun. Okay, so I'm letting x equal 2. I'm going to have my x's be in red here to help us track what's going on when we find the y that goes along with it. So we know that y equals negative 2 times x, because this is just coming back from this equation up here, right? That's the equation that we're using. We're saying that the x value now is 2. That was the one that we chose. We just kind of pulled that out of thin air. Minus 4. So y equals, watch your order of operations and watch your signs. Negative 2 times 2 is negative 4 minus 4. And negative 4 minus 4, that would give us a value for y of negative 8. So when my x value is 2, my y value is going to be negative 8. So that takes me all the way down here. Now I can see at the rate that I'm going that I'm about to fall off my graph down here. So I'm actually going to choose a negative value. I want to get some points over in this area of my graph. So I'm going to let x be, oh, I don't know, let's say negative 3. And again, there's really no rhyme or reason to this. I'm just kind of pulling up some values that I think will be relatively easy to work with. So negative 3 for my x value. And what y goes along with that? Well, let's find out. Y equals negative 2 times x. So my x value is negative 3. And then I'm going to subtract 4. You might be saying, wait, where are those numbers coming from? Remember, that's all coming from this equation right here. So that's all I did here is I just put in my value for x. So I chose negative 3. So I put that in here, but everything else in the equation is still the same. So y equals negative 2 times negative 3. It's going to give me positive 6 minus 4. So in this case, y equals 2. So when x is negative 3, y is going to equal 2. So I can plot that point right there. Now I've got my 3 points, and I can find my line, and then we're going to look at what the intercept is. Well, it turns out that we already know what the intercept is, but we want to just look at our line as well. So let's grab our ruler, Just like you would do by hand, you're going to bring the ruler over and you're going to line it up. And these should all line up perfectly. If they don't line up perfectly, that means we made a mistake somewhere. So I'm going to line up my straight edge and all of those points line up just exactly right. And so I'm going to grab my pen and I'm going to draw my line. And I'm going to put arrows in both directions because this is going to continue past where my points are. Let me just get rid of my straight edge now that we're done with that. Delete that. And so let's get our arrows on our graph here. Okay. So there we've graphed the equation. We've graphed the equation y equals negative 2x minus 4. And notice the y-intercept, if we remember what the y-intercept is, it's where the graph crosses the y-axis. Well, there's that point where it crosses the y-axis right there at the point 0, negative 4. That's my y-intercept. And notice we knew that that was our very first point because whenever we would let x equal 0, we're going to for sure have the y-intercept. Because what does it mean to be a y-intercept? It means that we're on the y-axis. This is our y-axis here, right? And here's our x-axis. If we're on the y-axis, that means we can't have moved either direction on the x-axis. We couldn't have moved to the left. We couldn't have moved to the right. We have to move 0 in the x direction. So whenever x equals 0, in an ordered pair, we're guaranteed that we're going to have a point on that y-axis. So that's for sure going to be our y-intercept. So we've taken care of all the things this problem was asking us to do.